Hello, and myself Vidinesh, and my roll number is 536, and my topic is about data flow analysis. In compiler design, code optimization is a program transformation technique that tries to improve the intermediate code to consume fewer resources such as CPU, memory, etc., resulting in faster machine code. There are two types of code optimization techniques: local optimization and global optimization. In local optimization, this code optimization applies to a small block of statements. Examples of local optimization are variable or constant propagation and common sub-expression elimination. Global optimization. This code optimization applies to large problem segments like functions, loops, procedures, etc. An example of global optimization is data flow analysis. What is meant by data flow analysis? Data flow analysis is a global code optimization technique. The compiler performs code optimization efficiently by collecting all the information about a program and distributing it to each block and it and its control flow graph. This process is known as data flow analysis. Since optimization has to be done on the entire program, the whole program is examined and the compiler collects information. The control flow graph represents a program in blocks depicting how the control of the program is being passed from one block to another. Basic technologies of data flow analysis are: there are some basic terminologies related to data flow analysis. There are three basic terminologies, that is definition point. A definition is a point in a program that defines a data item. A reference point is a point in a program that contains a reference to a data item. An evaluation point is a point in a program that contains an expression to be evaluated. The below diagram shows an example of a definition point, a reference point, and evaluation point in a program. In this figure, we can see that expression L1 is stores value x is equal to 5, means it is a definition point, and in expression L2, y is equal to x, means y is reference to x, and in expression L3, z is equal to a plus b, means a and value b are evaluated. Data flow analysis equation. The data flow analysis equation is used to collect information about a program block. The following is the data flow analysis equation for a statements: out s equal to gen of s union in of s minus kill of s, where out of s is the information at the end of statements. Gen of s is the information generated by statements. In of s is the information at the beginning of the statements. Kill of s is the information killed or removed by statements. The main aim of the data flow analysis is to find a set of constraints on the S ins and outs for the statements. The constraints includes two types of constraints: the transfer function and the other one is control flow function. In transfer function, the semantics of the statements are the constraints for the data flow values before and after a statement. For example, consider two statements x is equal to y and z is equal to x. Both these statements are executed. Thus, after execution, we can say that both x and z have the same value, that is y. Thus, a transfer function depicts the relationship between the data flow values before and after the statement. There are two types of transfer functions: forward propagation and another one is backward propagation. There are two types of transfer functions. Forward propagation. In forward propagation, the transfer function is represented by f's for any statements. This transfer function accepts the data flow values before the statement and outputs the new data flow values after the statement. Thus, the new data flow or the input or the output after the statement will be out of S is equal to in of S backward propagation. The backward propagation is a converse of the forward propagation. After the statement, a data flow value is converted to a new data flow value before the statement using this transfer function. Thus, the new data flow or the output will be in of S equal to f of S, means out of S. Control flow constraints. The second set of constraints comes from the control flow. The control flow value of Si will be equal to control flow values into Si plus 1 if block B contains statements S1, S2, so on up to Sn. That is, in of Si plus 1 equal to out of Si for all I equal to 1, 2, 3, up, so on up to n minus 1. Some properties of data flow analysis are available expression, reaching definition, live variable, and busy expression. Available expression. An expression a plus b is said to be available at a program point x if none of its operands get modified before their use. It is used to eliminate common sub-expressions. An expression is available at its evaluation point. Example, in the below diagram, the expression L1 4 into I is an available expression since this expression is available for blocks B2 and B3 and no operand is getting modified. As we can see in the figure, block B1 contains L1 expression 4 into I and block B2 Y is a reference to X and in block B3 P uh, L1 value L1 is multiplied into 3 is stored in variable P in block 3. So here the available expression is B1 since block B1 is available for to evaluate for the block B2 and B3. Reaching definition. A definition D is reaching a point X if D is not killed or redefined before that point. It is generally used in variable or constant propagation. Example, in the below diagram, D1 is a reaching definition for block B2 since the value of X is not changed. It is 2 only, but D1 is not a reaching definition for block B3 because the value of X is changed to X plus 2. This means D1 is killed or redefined by D2. In this block B1, D1 expression X is equal to 2 and in D2 expression X is equal to X plus and in block 3 D3 expression is Y is equal to X plus 3. In block 2 D1 is reaching definition for block 2 but block 1 D1 is not reaching definition for block 3 because the value in the block the value of X is changed in block 2. Hence D1 is being killed by D2 because the value is changed for X. So the block 3 D1 is reaching definition for D2 and D1 is not reaching definition for D3. Live variable. A live variable X is said to be live at a point P if the variable's value is not killed or redefined by the same block. If the variable is killed or redefined, it is said to be dead. It is generally used in register location and dead code elimination. Example, in the below diagram, the variable A is live at blocks B1, B2, B3, and B4, but is killed at block B5 since its value is changed from 2 to B plus C. Similarly, variable B is live at block B3, but is killed at block B4. As you can see, at block B1, value A is defined, and in block B2, values for C, the value is defined, and in block 3, the constant B is defined. At block B4, B value changes from A to A plus 3, and A value and in B5, A value changes from 2 to b plus c. So at block b5, the constant a is being killed, and hence it is not a live variable at block b5. And at block b5, b is also killed because the value of b is being changed, since it is not a hence b is not a live variable. Busy expression. An expression is said to be busy along a path if its evaluation occurs along that path, but none of its operand definitions appears before it. It is used for performing code movement optimization. Conclusion. In this, we have studied data flow analysis in code optimization. We went through the concept thoroughly, discussing the basic terminologies, data flow analysis equation, and properties. That's it. Thank you, everyone.